The book does address that you can use binomial tables to calculate a binomial probability. This technique is not used very often because we have calculators, but just so that you're aware, you can use this table here for an n of 10, and here's your x down here and your probability. You can find that binomial probability. We can calculate the mean and the variance and standard deviation of the binomial distribution. Again, that mean is your expected value, and then we can also look at that distribution or the dispersion of those probabilities. Here's just a demonstration of how your mean and your standard deviation can affect the shape of your distribution. We can use Excel and Minitab to calculate the binomial distribution as well. So we've gone over the binomial distribution for discrete variables, and the next distribution we'll be discussing is the Poisson distribution. So you want to use the Poisson distribution when you're interested in the number of times an event occurs in a given area of opportunity. So an area of opportunity is defined as a continuous unit, and it can be time, volume, or an area in which more than one occurrence of an event can occur. So here's some examples of that area of opportunity. So the number of scratches in a car's paint, the number of mosquito bites on a person, the number of computer crashes in a day. You see the opportunity here is, the car's paint, the car as a whole, the person, their body, and then in a day is an area of opportunity. Just like the binomial distribution has certain characteristics, so does the Poisson distribution. So you want to apply the Poisson distribution when you wish to count the number of times an event occurs in a given area of opportunity. So for example, if I am interested in the number of customers that come into my restaurant during the lunch hour, I want to count the number of times a customer comes in every single minute. So the probability that an event occurs in one area of opportunity is the same for all areas of opportunity. So going back to my restaurant example, the probability that people will come in the first minute should be the same as the second minute, third minute, and so on. The number of events that occur in one area of opportunity is independent of the number of events that occur in other areas of opportunity. So just because I got 3 customers in the first minute does not influence the number of customers I'm going to get in the second minute, or the probability that I'm going to get a certain number of customers in the second minute. The probability that 2 or more events occur in an area of opportunity approaches 0 as the area of opportunity becomes small. So there's a certain probability that 2 customers can come at the same time in that minute. However, if I shrink that area of opportunity to say 30 seconds, that probability that 2 customers will come in that 30 seconds is much lower. And again, if I reduce that area of opportunity to say 10 seconds or 1 second, the probability that 2 customers will come in that given second becomes much smaller. And for the Poisson distribution, the average number of events per unit is denoted by lambda. So if you see this lambda, just know that it is referring to the average number of events in a Poisson distribution. Here's that Poisson distribution formula, where x is the number of events in an area of opportunity, and we also use lambda as well as the base of a natural log. Again, no need to memorize this formula. This is something that is very interesting about the Poisson distribution. For the mean of the Poisson distribution, the mean is equal to the expected number of events. And the variance is also equal to the expected number of events. So your mean and your variance end up being the same value for the Poisson distribution. Like you could use the binomial tables, you can also use the Poisson tables here. Again, we typically don't use these nowadays because we have calculators to quickly calculate this out. We can also calculate the Poisson distribution in Excel and Minitab. And this is just a graphical representation of the Poisson probabilities for this lambda here. It is important to note that the lambda does affect the shape of that distribution. So in terms of the binomial and Poisson distributions, I would like you to know when you should use each. So let's practice here. Go ahead and pause the video and try to determine which distribution should be used to evaluate these questions. So how many customers come into the store on Monday? How many have customers purchased this particular shirt? How many times does a cash register malfunction in a given week? Are employees working less than 40 hours? And how many phone calls do we receive when the shop is closed? And here are the answers. How many customers come into the store on Monday? Here we have an area of opportunity, which is a continuous area of opportunity. So we're going to use a Poisson distribution. Have customers purchased this particular shirt? This is a whether or not question, right? Did they purchase this shirt or did they not? So that is a binomial distribution. How many times does the cash register malfunction in a given week? Here we have the area of opportunity of a week. And so we're going to use the Poisson distribution. If I were to randomly pick an employee, what's the probability that that employee is working less than 40 hours? This is a binomial distribution, right? Because they're either working less than 40 hours or they're not. And then how many phone calls do we receive when the shop is closed? So in a given minute or in a given hour when the shop is closed, how many phone calls do we receive? What's the probability that we'll receive a phone call? We want to use the Poisson distribution because we have an area of opportunity here. So again, this chapter is filled with a lot of equations, but I do want you to know kind of these important concepts here. So what is a probability distribution? What is an expected value and how do you interpret it? So expected value, again, is just that mean. Know the characteristics of a Poisson and a binomial distribution. And if you know those characteristics very well, then you should also know when to use which. So the quiz is a great way to see the kind of content that I would like you to know for the exam. Again, you'll probably see questions much like this. And that's the end of Chapter 5.